Hi there. Thanks for joining us again for Space Nuts. My name is Andrew Dunkley, where we are talking astronomy and space science every week with Professor Fred Watson. Coming up on this episode, have we discovered a primordial black hole? I believe this has been up for discussion before, but we might have some new information for you. Good news from the Murchison Wide Field Array, and Mark II of the space race could see China in the lead. We'll tell you all about that on this episode of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Yes, and this episode proudly supported by SpaceX. It's like trying to land an unmanned rocket back on a floating pad is how it feels at the moment. Very unstable internet connection. And yes, this is take two, believe. We did the whole show and had to start again, didn't we, Fred?
Yeah. Something like that, yeah.
I think we got 10 seconds in. Yeah. T-minus 10 and the whole thing went. How are you, Fred?
I'm very well, thank you. It's great to see you, Andrew. Good to see you looking a bit less jet-lagged than the last time we were together. Yeah,
and I'm wearing my DART T-shirt.
Yeah,
which Marie Claire sent me from the DART mission when she witnessed the impact moment at NASA. So, yep. And Geordie, hello, Geordie.
Yeah, Geordie's still there. He's kind of well, he howls at things when he gets a surprise. He starts howling, and he's surprised at the moment because I've got washing outside on the line, and every time the wind blows, he thinks it's a threat, so he howls. And it's quite a windy day, so we're probably
it is here too. Yeah. Yes. Well, dogs and cats living together. That's the world we're in at the moment. We'll get straight to it, Fred. Now, there's been a lot of movement in the news about the potential discovery of a primordial black hole that may have formed not long after the Big Bang itself, which is something that was predicted by Stephen Hawking. And it was. Look, they have not exactly confirmed it. In fact, that might be very difficult. But if it's real, this is a very exciting discovery indeed. But there's a bit more going on than that. I know you've probably talked to Heidi about this, but this one came up in Facebook discussions. And so we thought we'd bring it up on the show.
Definitely, Andrew. It's because there's a new paper as well, which is... Actually, Science Alert describes it as a dazzling new paper, which is pretty good, coming from the University of Cambridge. I used to know all the people in Cambridge who are working on this stuff, but that's a long time ago, and I don't know them anymore. I don't know Ines Yordsbalis, I think is their name, and that is a lead author of this paper. What we talked about in your absence, Andrew, while Heidi was in the hot seat, was these little red dots, which is becoming the official name for targets that the James Webb Telescope has identified as little red dots, because that's what they look like.
Yeah.
But they you can measure their redshift, and it turns out. And the reason they're red is that their light has been stretched so much because they are actually, we're seeing them at a look-back time of something like 13.2 billion years. Remember, the universe, we think, is 30.8 billion years old. So we're seeing these 600 million years after the Big Bang. So no wonder they look like little red dots. They're little because they're so far away, and they're red because they're highly redshifted. And the dots because basically you can't see any structure. And that's the interesting part of this, because they are assumed to be galaxies. And in fact, all the evidence is that they are indeed galaxies, but they're galaxies with not many stars. Stars, at a much lower density than we find in stars today. Yeah. And so the most notable feature of them is a central black hole. And how do we know that there's a black hole there? Because you can sense the rotation. If I remember rightly, you're seeing velocities of well over 1,000 kilometers per second of material, which is going round in orbit around something, and that something has to be a black hole because there's nothing else could fit into the squeeze into the small space that it's occupying. So what they've basically discovered, and they're talking, this is Cambridge University group is talking specifically about one particular object. It's called QSO1. It's a odd name because QSO is a standard contraction of quasi-stellar object, QSO, quasi-stellar object, something that looks like a star but isn't. Yeah. I suppose it is. It does look like a star but isn't. But we now identify QSOs with quasars, and it may be a quasar, but we're not seeing the outbursts of X radiation that we normally get from quasars. So what is being suggested is that what we have here is a black hole, yes, apparently 50 million solar masses, something like that, which is big compared with our poor little 4.1 million solar mass black hole at Sagittarius, a star in the center of our galaxy. So it is a supermassive black hole. I mean, it's not the behemoths that have billions of solar masses. It's not that big, but it is big. And the fact that it's 50 million solar masses, and we're seeing it as the universe as it was 600 million years after the Big Bang, begs the question, how did it get so big?
Yeah.
And so basically, the bottom line is that it could be that we are seeing, as you've said, primordial black holes, which indeed were predicted by Stephen Hawking, among others. These things should develop after the Big Bang, and there are subtleties here, and I might quote one of the authors. It's actually, this is a quote from the paper itself, and we're talking now about something that's got high mass but not many stars. The only scenarios that can account for such a system are those invoking heavy seeds, and that's in inverted commas, such as direct collapse black holes, which are called DCBHs, direct collapse black holes, resulting from the direct collapse of massive pristine cloud. So that is saying is you've got a cloud of gas, it collapses, it doesn't form stars, it just collapses straight into a black hole. And you and I talked about that some years ago, the idea of these direct collapse black holes. So that's one possibility for what this is, or primordial black holes formed in the first second after the Big Bang. Now, what they say is, in fact, this is the article, reading it from Science Alert. It's a very nicely written article. I should name the author. It is Michel Starr. What a name for somebody who writes about astronomy. Michel Starr says both scenarios would need further investigation. On the one hand, direct collapse black holes would be accompanied by ultraviolet light not seen in QSO1. On the other hand, PBHs, primordial black holes, are considerably smaller than 50 million solar masses. It is possible, however, that the object is the product of rapid growth, both through accretion, that's just gathering stuff up, and collisional processes, that's black holes colliding, making QSO1 potentially the first direct evidence for the existence of primordial black holes. And so, it's now, that's where the situation lies now, that we don't have a definite answer. And once again, Michel says the paper remains to be peer-reviewed, and it is quite an extraordinary claim. So we'll be waiting to see how this line of inquiry develops. So will Geordie. Whatever the outcome, though, we're sure that little red dots are going to tell us something really fascinating about the birth of the universe. So it's an ongoing story, Andrew. It's an evolution of what we talked about with Heidi. But I think you and I will be talking about this again quite soon, probably.
Yeah, I don't doubt it. And it'll spawn a lot of questions too, I'm sure. When you think about it, though, if it's been around for 13.2 billion years, it's had plenty of time to get its stuff together, to grow and to develop I suppose. 50 million.
50 million solar masses. But remember, we're seeing that 13.2 billion years ago. So
what's it like?
Who knows what it would look like now? That's right. Yeah. Yeah.
Fascinating story. Yes. Plenty of places where you can read up on that, phys.org or sciencealert.com. And many others carrying this story, because if it turns out to be what we think it is certainly quite a discovery. This is Space Nuts. Andrew Dunkley here with Professor Fred Watson. Let's take a moment to talk about our sponsor, Insta360, the Go Ultra, a pocket-sized camera that's redefining how you capture life's adventures. Imagine a camera no bigger than an Oreo, weighing just 53 grams. It's small enough to slip into your pocket, but delivers professional-grade footage that'll make your vlogs, travel diaries, or family moments look absolutely stunning. Its magnetic mounting system lets you get creative with your shots in seconds. Clip it to your shirt or hat for hands-free point-of-view footage while you're running, biking, or chasing your kids around the park. Or stick it to any magnetic surface, think bike frames, gym equipment, or even a street sign, for unique angles that no other camera can match. The standalone camera is IPX8 waterproof up to 33 feet, so whether you're surfing, swimming, or caught in the rain, it's ready to roll. Low-light scenes? No problem. The Pure Video mode uses AI to reduce noise and boost dynamic range, so your nighttime adventures shine. Battery life? The Go Ultra's got you covered with a next-gen stacked polymer battery. The standalone camera runs for 70 minutes, and when paired with the Action Pod, you get up to 200 minutes of shooting time. Need a quick recharge? Plug it in, and it hits 80% in just 12 minutes. For the first 30 Space Nuts listeners who purchase the Insta360 Go Ultra at store.insta360.com, you'll score a free sticky tabs accessory to mount your camera on anything from backpacks to winter jackets. Just use the promo code SPACENUTS at checkout. That's store.insta360.com, promo code SPACENUTS. Check the description for links and more details. Don't miss out on this tiny titan of a camera that's ready to capture your world like never before. Now, back to the show.
3, 2, 1.
Space Nuts.
Now, Fred, a little closer to home, Western Australia to be exact. Good news coming out of the Murchison Wide Field Array.
Yes, that's right. This is a story I like a lot because I've always been a big fan of the Murchison Wide Field Array. It's a Curtin University-operated set of antennas at the observatory. It's called Inyarimana Ilgari Bundara, the CSIRO Murchison Radio Astronomy Observatory. That's its full name. Inyarimana Ilgari Bundara is Wadjuri language, and it means sharing sky and stars. And the Wadjuri people are playing a big role, actually, in the development of the square kilometre array low frequency arm, if you can put it that way, which is also being built there. And in many ways, the Murchison Wide Field Array, the one we're talking about now, was the precursor to that square kilometre array telescope, because unlike the traditional steerable dishes, and in fact one of the pathfinders for the square kilometre array was steerable dishes here in Australia, again at Murchison. Unlike those steerable dishes, these antennas look like something different. So in the case of the square kilometre array, and we've discussed this many times, it's paddocks full of Christmas trees, metal Christmas trees, 131,000 of them. That's still a work in progress. We talked recently about the images received from the first 1,000 of those antennas. But the Murchison Wide Field Array is a different style of thing, but it's the same kind of idea, except their antennas look different. They are not 2 metre tall Christmas trees. They're about 0.5 metre tall and about 3/4 metre wide. Read yards for that if you're not in metre land. But they look like, well, the first time I saw them, and I have visited this site, first time I saw them, I thought they just looked like a field full of coat hangers that somebody's thrown away. They've just sort of assembled themselves in a peculiar way.
Oh, yeah. I'm looking at a photo now, and
Yeah, do you see what I mean?
my first impression was metallic spiders.
Yeah, that's right. They've got that about them as well.
Yeah.
The reason I remember being really impressed. So they're like, so each one of these, as I said, is 0.5 meter wide. It's made of metal. It's shiny. It's got basically 4 legs, so it's a 4-legged spider. But it's got these structures that look just like bits of bent coat hanger. But it sort of spells its own name, because you can make each one of those antennas give you an M, a W, and if you look sideways, an A, which is the Murchison Wide Field Array. I always thought that was very clever. I think that was completely accidental, because when I talked to the Murchison people, they'd never thought of that. They thought it was crazy, actually. So it is in the news because the phase 3 of the development has now been completed, and phase 3 was doubling the number of antennas. It was originally 4,096 within a 20 square kilometre area, quite a large area, but it's gone up now to a total of 8,000. I can't remember the exact number. It's just over 8,000.
8,192.
I should have done it because it's double 4,096. Yeah, could have probably done that in my head, but never mind. I couldn't. It's been a long day. It's out to 30 square kilometers, and that actually, so doubling doubling the number of antennas basically doubles the sensitivity, at least at some level. Expanding its footprint from 20 to 30 square kilometers actually increases what we call the baseline of the array, and that's sort of the equivalent to the width of a mirror. If you were thinking of a visible light or optical telescope, the diameter of the mirror is what tells you how much detail you can see. And in a way, what they've done is they've expanded that footprint out to 30 square kilometers, and so it will let you see more detail. Higher resolution is the technical term. Basically, it lets you see finer detail in whatever you're looking at. And so they've done all that. It's not just the coat hangers that you have to expand. All the software, the hardware, things called the correlators, which are basically supercomputers that combine the signal from each coat hanger to turn it into a coherent image. That's all new as well, and so it's a really significant increase in the capabilities of the MWA. And what they're Sorry, go ahead.
No, you're probably about to answer the question I was about to ask, because it said one of the primary focus areas of this effort was the epoch of reionization. What does that mean?
Yeah, so that's the time, effectively, not long after the Big Bang, when the universe became transparent. You know, one of the reasons why we build these huge radio telescope arrays is to probe an era after the Big Bang, but before the first stars and galaxies lit up, where basically the universe was just full of cold hydrogen. And cold hydrogen, curiously, does emit radio waves. It emits them at a frequency of 1,420 megahertz, if I remember rightly. We used to call it the 21 centimeter line because that's its wavelength, but I think these days we talk in frequencies, and I think it's 1,420 megahertz. I'm not a radio astronomer, so I have to try and remember these numbers. They don't come intuitively, although 21 centimeters does, because I think a lot of astronomers know about that stuff. Anyway, that's the wavelength or the frequency that cold hydrogen emits. And that's very convenient because it means that you can find cold hydrogen in the universe, and your radio waves pass through the dust of the universe as if it wasn't there. That's why with visible light telescopes, we can't see the spiral arms of our galaxy, but you can with the radio telescope, because you can trace out where the cold hydrogen is. Cold hydrogen hangs around on spiral arms of galaxies. But it was also there in the early universe. The cold hydrogen was the raw material of the first stars and galaxies. So that epoch of reionization corresponds to a time when the first stars and galaxies switched on, and the radiation that they spread out into the universe basically made the universe transparent. That's the bottom line.
Right.
And so that can be detected, the signal of that can be detected by radio telescopes. And the MWA, I think, if I remember rightly, talking to my radio astronomy colleagues, I think it was built specifically for that, to look for the epoch of reionization, the time when the universe started to transmit light. So fantastic stuff. It's a $5.5 million Australian dollar upgrade, but I think that's to be like money well spent.
Yeah, $10 US. So
soon to be $1 million US.
Boy. Is that all it's going to do? I mean, is it a case if you had one job?
No, that's right. And you didn't do it. I mean, people have been telling me that all my life. Anyway, look, there's a lot of other things. Now, one of the things that it should be able to detect is fast radio bursts. But my recollection from talking to MWA scientists was that the original version, the 4096 antenna version, never did detect a fast radio burst. And that's interesting because fast radio bursts, perhaps it's telling you that they don't emit in the lower frequencies, which the MWA, the Murchison Wide Field Array, is tuned to. It's a low frequency array, and it's the higher frequencies where the fast radio bursts have been discovered so far. But I think the improvement in sensitivity will actually allow fast radio bursts to be detected, and then we might start finding very large numbers, because the trick that I didn't mention that the MWA is able to employ is it can look at the whole sky at once.
Oh, yeah.
Pretty impressive.
Good trick.
Yeah, that's what you can do with an array of coat hangers rather than a dish that you've got to point in a particular direction. These coat hangers are bringing signals in all the time, and it's just how you interrogate them, if I can put it that way, that tells you where you're pointing, and you can interrogate many, many different directions at once.
Yeah, quite amazing. So, and how much bigger are they going to make the MWACs?
I think phase 3 might be the final thing. I remember them talking about phase 3. Well, I visited there in 2018. I visited the site and saw the array antennas, the coat hanger-like things. But a bit later than that, I also visited their headquarters, which are in Perth in Western Australia. And they were. This is probably 5 years ago now, 5 to 6 years ago. They were talking then about the next phase, but I think that was where their horizon lay, and it may well be that that's the end of the story for the MWA. But I'm going to preface that, or not preface it, but qualify it by saying that could be just based on information that was probably good 6 years ago, but might not be good now.
Yeah, well, that's the way it goes sometimes.
Certainly goes with us, doesn't it?
Yes.
We're always out of date.
Yeah, well, that's
Sometimes only a few days, but yeah.
Yeah, that's astronomy. We're 13.8 billion years out of date sometimes. If you would like to read up on that story, universetoday.com or spaceconnectonline.com, or just do a search for Murchison Wide Field Array on your favourite search engine. This is Space Nuts. Andrew Dunkley here with Professor Fred Watson.
0G, and I feel fine.
Space Nuts.
Our final story, Fred, is another goodie, and a bit of a controversial one too. We've talked many times about Artemis and the race back to the moon, and there's quite a few missions sort of trundling around up there. The Indians are having a crack as well. But the space race, as we witnessed it through the 50s and 60s and into the 70s, has sort of got a phase 2 of its own going on at the moment between the US and China. And if you ask some people, they're saying China might win this.
And in a way, perhaps just coming to maybe what the reasoning is behind this. The US has got a very, very ambitious vision for the Artemis project. And that's what's taking astronauts to the moon by NASA. Their vision, and what, the point is, it's not just planting flags and boots on the ground, which is what the Apollo missions were.
That's right.
It's much more than that. It's actually kind of setting the stage for a permanent lunar base. It's doing things like being able to refuel your spacecraft in orbit and transfer fuel. It's having the necessary spacecraft to land you on the moon. And that's the vision of NASA, which is a lot different probably from China's vision, which will be just to get boots on the ground and plant a flag. And that now is something technologically a lot simpler, because it's what they did in the Apollo era, but it's technologically a lot simpler than what Artemis is aiming to do. So the story comes about because of it was a US Senate Committee on Commerce, Science and Transportation. So this committee had testimony from various individuals, and perhaps the most notable was the former NASA administrator. Remember, the boss of NASA is called the administrator. Mm-hmm. His name was Jim Bridenstine. He was a very well-known and very well-respected NASA administrator. I think he was followed by Bill Nelson, who's the only one I've met. He and Bill, too, a very well-respected administrator who basically left his post at the time of the new government in the United States. But Jim Bridenstine making a comment that he considered that because of the complexity and perhaps questioning even the feasibility of NASA's Artemis program, he thinks the United States is highly unlikely, and that's his words, highly unlikely to land astronauts on the moon before China because of challenges with, as it's described, orbital refueling and an ambitious architecture. So the architecture is just, what is the structure of this mission? How do you do it? What kind of spacecraft do you use? Where do you put them? What do you do in orbit? The hearing actually has a provocative name itself. The hearing was entitled "There's a Bad Moon on the Rise: Why Congress and NASA Must Thwart China in the Space Race." So it's really quite an interesting one, and it's got, it's got congressmen, congresswomen from both sides of politics. I think the issue that Bridenstine highlights is, well, there are a few. One is that the SLS, the Space Launch System, which you'll remember has been tested out once with a robotic fly around the moon. That's probably, was it 4 years ago now? Yeah. It's quite a while ago. And he describes it as extraordinarily expensive. And I guess by the standards of 2025, that is probably right, because we are used now to a company that reuses all its launch vehicles. I saw that SpaceX has flown one of its Falcon 9 boosters 30 times. And wow, that's amazing. They were talking about limiting it to 10 times, but this one's done 30 launches. And these, of course, are for Starlink communication satellites. But the SLS is the sort of Rolls-Royce of launch systems. It is very, very expensive. But Bridenstine advocates that for continuing to use it because it's already there, it's already developed. But his complaints are twofold. One is that in order to do what Artemis will do, you need to be able to refuel spacecraft in orbit. And these are cryogenic fuels, the temperature's minus 250 Celsius or something, that ridiculously cold. That has never been done before. And that has to be done in order to make this work. And the other complaint is that the lunar lander is basically still untested. So there were 2 contracts awarded for what's called the HLS, the Human Landing System, to develop 2 vehicles. One is the Starship, SpaceX's Starship, and that's the top end. Starship itself is the Falcon Super Heavy booster and what they call the ship, which is the top end of it. And the ship will also be the lander, the HLS lander, for Artemis 3 and 4 missions. Now, Artemis 3 is going to be the first mission to land astronauts back on the moon. Artemis 2 will be a lunar orbit mission. But then they also contracted Blue Origin's Blue Moon Mark II, which is another landing system for Artemis 5. Now, none of these really have been tried and tested yet. SpaceX is talking about some upcoming missions which they hope will be what is required to prove the Starship version. I'm not sure where Blue Origin is, but so the complaint is by Bridenstine that we're so far behind with all this. There's a really good chance that the Chinese will get there first. Go ahead.
Does it matter? Does it really matter? They have completely different goals, completely different agendas.
Yeah.
Does it really matter if China lands on the moon and starts walking around before the United States does? Is there some advantage in them doing that? Because they're not trying to achieve the same end as the United States, as NASA. So, and the US already proved that they were first back in 1969. So it's not really a race, is it? Not that kind of race.
Don't you think if China landed astronauts on the moon before the US did, the president would implode, wouldn't he? Or something would.
Yeah, but are they? It's just politics, isn't it? I mean, it's just posturing. The US has already done it. They don't have to do it again before China because China, they did it before China. So
yeah, I think national pride is playing a huge part,
probably,
one that we might not recognise to the extent that perhaps some of our listeners will. I think it would be a real challenge to the US if China landed first. I think it really would
in this year
shake them to the core. Yes, okay. A little bit like when the Soviet Union put the first artificial satellite into orbit. I remember the fallout from that. It was, I was still a youngster. I was only 10. What was that? No, I was 12. Anyway, it was, it was there. It absolutely shook the US to the core that the Soviet Union could put a spacecraft into orbit, which meant they could launch a ballistic missile anywhere on the planet or land one anywhere on the planet. So that's the underlying thing. Now that imperative's gone. Everybody knows that there's half a dozen countries who could land a ballistic missile pretty well anywhere on the planet. But I think it's the national pride issue. I think it would be seen as an affront almost to US pride in space. What is going to happen about it? I don't know. I don't know whether this hearing will actually produce any changes, but be interesting to see how it goes.
It will, yes. You can read all about it at nasaspaceflight.com. Very interesting article indeed. Fred, we're done. That's it.
Good gracious.
Episode just for this episode. Yeah, episode 555. Yes, I didn't mention that, did I? Yeah, 555. I don't know. Is that a lucky number in China? Or is it AAA? I don't know. Yes. Anyway, Fred, thank you so much. It's always good fun.
It is. Thank you for having me, Andrew. I hope I'll be invited back sometime.
Maybe in 5 minutes, 5 days, whatever comes first. Yes, you never know. Thanks, Fred. Professor Fred Watson, astronomer at large, part of the team here at Space Nuts. And, of course, thanks to Hugh in the studio, who couldn't be with us today, had to put his cat Sputnik down, unfortunately. I don't know where that came from. And from me, Andrew Dunkley, thanks for your company. We'll see you on the next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.